with their own answers that I may have probably not heard? Anybody?
Yes, sir.
Oh.
0.965.
Oh, 965.
Yes, sir.
Okay. What's your name, please? Let me register your answer.
Chukwemeka.
Chukwemeka. Okay. Your voice sounds different today. Are you Chukwemeka? Okay. So 0. Please come and answer again. 0.0965, right? What's your answer, please?
0.965.
Okay, 0.965. Sorry, 0.965. Okay, let's solve together. Let's see the correct answer. So this is question 25, which is this one here, right? So we have 0.9253, no, 0.925 cube divided by the square root of 0.673. 0.673. And we are told to evaluate using logarithm tables. So let's now go ahead and solve. So our first step is to write the numbers as well as their logarithm. So the numbers as well as their logarithm. Now the first 0.925. Before I put this power of 3, what will be my characteristic?
Bar 1.
Bar 1, right? Correct. So I will have bar 1. Then I'll now have 92 under 5. So let's go to my table of logarithm. Let me pull that out. (92) under 5. Okay, I think I'll just get it from here since I have it here. Because I'll just pull it from my table here. Please, if you have yours also, please follow me also so that we can work together. All right, so we're looking for 92 under 5. Now this is my table of antilog. So I'll go to my table of logarithm. 92 under 5. So we have 92 here. Let me zoom in. Okay, I think this should be enough. So 92 under 5, what does that give me? Here is 92. Under 5, I have 0, 1, 2, 3, 4, 5. What does that give me?
So gives you 9661.
Correct, 9661. 9. Yes, that's 9661. So I have 9661. And then if I carry its power, which is raised to the power of 3, what would that be? That means I will multiply by 3.
By 3, yes, sir.
So what does that give me?
1.8983. By 1.8983.
Okay, everybody, same answer?
Yes, sir.
So is it the minus 1.9661?
Yes, I'm multiplying this by 1.9661 by 3.
So when I did it, I actually separated the bar 1 from the 9661.
No, you don't do that. You only do that when you are dividing for convenience. When you are multiplying, it's easy. You know, if you multiply 3 by 1, for example, you get minus 3, something like that. So you don't separate. You only separate for division. Let's do it here.
But when
So I have
so
about 1.9661 and we're multiplying by 3.
Sir, quick question. So that bar 1, it should be minus 1.
Yes, yes, you take it as minus 1, yes.
I pressed the calculator here. That is minus 1 point, and it gave me minus 5 point something as answer.
No, you know that this notation here is showing minus 1 in terms of standard form. Remember, to get characteristic, when you write this in standard form, to be 9.25 times 10 to the power minus 1. Not that the actual number here is minus 1. So you can't just use minus 1 on the calculator. this is a notation to show that the standard format of this is carrying -1 in the power. You get that?
So are we just meant to multiply the 9661?
You can multiply the 96. Another way to do it is you can multiply the 0.9661 like Anita said. You can separate it and then multiply, but it's going to be complex. Instead, what we do is that we usually separate it when we are dividing.
But sir.
Yeah.
When I separated it, I still multiplied it by 1, which gave me by 3, and then I
Added it.
Yes, I also multiplied the decimal part and I added it together, which gave me by 1.8983.
Okay, that's
correct.
That's also correct. So only that separating it is cumbersome. So it's best you only leave
But
it.
sir, what if you understand it like that?
Well, I would say do what works for you. As far as you understand it, that's what is more important. But for me, in terms of preference, I prefer to multiply straight away, since I can just take this as -1. But let's do the multiplication straight away. But if you understand it like that, it also works.
Yes, sir, please, sorry. Sir.
Yes.
So that 0.925 raised by 3, what if you just times it like that? Then you will not convert it to log. Will you still give you the same answer?
What if you just do what?
So this 0.9253, like that one, you will solve it. Then convert the answer to log. Will it give you the same answer by getting this one by 1.8983?
So I'm not getting. You said what if we do what?
So at this 0.925 raised by 3 now is we'll solve it like that. Then convert
you have to in order to solve this, you have to convert it to logarithm first.
Okay, so you cannot solve it like that, then convert to logarithm.
Like, what do you mean by solve it like that? Let me understand what you mean. Like, you mean raise it to power 3? No, now the goal is for you to raise it to power 3 using logarithm. So you cannot just do your normal multiplication or calculator or whatever here. You have to do it in logarithm.
Okay, I understand.
All right. So you have 3 times 1 here is 3. 3 times 6 here is 18. So I have 8 carry 1. 3 times 6 here is 18. Plus 1 is 9. Then 3 times 9 here is 27. So I write down 7 and carry 2. Then my point is here, I leave it. 3 times bar 1 is -3. Then plus 1 is, plus 2 is 1. That's your own 1. That's bar 1. So bar 1.7883. So I write this as bar 1.7883. All right?
Sir, I still am familiar with the multiplication process.
So you say you are still what?
I'm not still familiar with the multiplication process for the logarithm.
Dimma network.
Okay.
So what is cracking? So you like it unstable.
What is cracking though?
Hello?
Do I hear you, sir?
Yes, sir.
All right. So let's continue. So you say you're not familiar with the multiplication process. So let's do that multiplication together. Now, like I said, it is similar to your normal multiplication. That bar, you just take it as -1. So let's redo it again. Right here, I've done the logarithm part, so let's do the bar. So right here, I have bar 1.9661. Bar 1.9661. And then you multiply by 3. Now let's do it together. Here is 3 times 1, the normal way, which is still 3. 3 times 6 is 18, write down 18. Sorry, write down 8, and then you carry 1. 3 times 6 is 18, plus 1 is 19. Yes, actually 9. And then you carry 1, right? 3 times 9 is 27, plus 1 is 28. I'll write down 8, and then take my 2. Now there's a decimal point here, so I leave it here. So 3 times bar 1. Bar 1 is like saying -1 in terms of the notation. It is a notation. It's not really a number. It's not like it's -1. But in the notation, it is signifying that the power of 10 in standard form is -1. So that's how we take the value of that notation. Are you getting me? Not that the number is -1. So this is 3 times -1, which is -3. Then -3 plus 2 is -1. So I'll write it as bar 1 because it is a notation, not a number. So I can't write it as -1. Do you get that?
Yes, it's clear now.
Yes, sir.
Yes, sir.
Yes, sir.
So that means here is not correct. Here is 8983. So let's correct that. Not even 79, it's 8983. Okay. So let's go on. So I've done the numerator. So I like to, like it's just what I want to do. I just like to name it. So I'll call it my numerator. So I know that, okay, this is numerator. Then divided by, so my numerator is divided by the denominator. What's my denominator? That's square root of 0.673, of which I can rewrite it as 0.673. Then I'll cube it. But first of all, let me do 0.673 first. Now, what will be the characteristic of this?
Bar 1.
Bar 1, right? Just count
Yes,
this. Don't need to bother yourself, right? So this is bar 1. So I'll look for 67 under 3. So let's look for 67 under 3.
8280.
8280.
Yes, 8280. So I have 8280. Now don't forget this square root, which means it's raised to power half. So that means I'll multiply by half, which basically is the same thing as dividing it by 2. Now this is where you also need to be careful in solving it. So let's take it. Now you have bar 1 point. Let me do it by the sides. So you have bar 1.8280, and you are dividing by 2. That's from this. Now, in order to divide this by 2, I will separate them. But to separate them, I know this will be bar 1 over 2 Wait, sorry, I just thought of something because I'll need this space. I'll need this space for something. So let me, because I'll need this space for something. Let me take it a little bit further. All right. So let's do that one here. So yeah, I want to do about 1.8. 8280, 8280, and I want to divide by 2. Now, in order to divide by 2, I will have to separate this as by 1 over 2, then plus 0. What's going on? This is not. Wait, please, my mouse. All right, so this is by 1 plus 8280, 8280, 8280 divided by 2. But by 1 cannot be divided by 2. So what will I do? I'll take this by 1 to something that is a multiple of 2.
Yes, sir. That will be by 2.
That will be by 2. Then divided by 2. Then what will I do to restore this? No, this is like saying 0.82. This is 0.8280. Now, here is by 1, but I've made it by 2. What will I do here? It will now be plus 1.8280. I hope we are following.
Yes.
So that's to balance it. This is 8280 divided by 2. So why did I add this one? You know, this is minus 1. So minus 2 plus 1 will give me back my by 1, which is notation for minus 1. So with this, you can now divide. So by 2 over 2 will give me by 1 plus, dividing this should give me 0.9140. Yes. And then when you add them all up, you now have by 1.9140. Yes. I hope that's clear.
Yes, sir.
All right. So let's now continue our work that we're doing. So in this numerator here, we had by 1.8948983. Then divided by, which you change to minus. Now, what did this one give me? In my denominator, so when I divided this, what did it give me? It gave me by 1.9140. By 1.9140. So let's bring that here. By 1.9140. By 1.9140. So it is numerator divided by denominator, right? As you can see, a numerator divided by denominator. So numerator is this, divided by changes to minus, then denominator is this. So I'll bring it here as, let me use a different color for it. So I'll bring it here as by 1 point, what is here? 9140. 9140. So let's do it. So when we do that, what does it give me? 3 minus this is what? 3. 8 minus 4 is 4. 9 minus 1 is 8. Now 8 minus 9 is not possible. So if you borrow 1 from here, here becomes 18. But what will here become? Then you're having minus 1, then you borrowed another 1. That's like saying minus 1, then you borrowed another 1. It will be minus 2 or bar 2. So let me write it as bar 2 that it has become. So yes, 18 minus 9 is 9. So now I have bar 2 minus bar 1. So this will be bar 2, taken as a notation for minus 2, minus bar 1, which is minus 1. So minus minus is what? Plus. So minus 2 plus 1 is still what?
Minus 1.
Minus 1, which is bar 1. So here's not my denominator. Let me not join those lines. All right, so this is the answer for the fraction. So we have bar 1.9843. So let's convert it back to numbers using anti-logarithm. So let's convert it back. So normally I'll look for 0.98 under 4 difference 3. 0.98 under 4 difference 3. 0.98 under 4. So this is 0, 1, 2, 3, 4, which is 9638. 9638. 98 under 4. Then difference 3. Difference 3 here is 7. Let's add 7. That gives me 9645. Are we together?
Yes, sir.
Yes, sir.
So this bar, all right, good. So this bar 1 here is showing me that there are many zeros, just 1. So I put that 1 and put my point. The answer is 0.9645. So Anita is correct. So the rest of us, okay, 9645. 965, let me assume that you approximated. Let me assume. So I'll give it half. Then this other one, I believe something must have happened to your bar here. What happened? Success.
Sir, I found my mistake.
Okay.
So my mistake was that place that this place that bar 1.8280 divided by 2. From there, that's why I made mistake.
Okay. There's no problem. As far as we are learning. So for the second one, what did we have?
So the second one, I got 0.2623.
2623.
Yes, 0.2623.
Okay, let's do the second one, which is 20. I think we skipped 27.
Yes.
So let's do it together. Let me get the question. Or if you have the question, you can help me with it too. Okay, let me just pull it out here. Question 20 is, this long thing. Yeah. Sorry, give me answer again.
0.2623.
0.2623.
Yes.
Any other one?
Wait for number the other one.
Yes.
I got 11.02.
Jesus.
Jesus, a big Jesus. So a very, very big Jesus. Who else?
The question is 27.
Yes.
Okay.
Who else now?
I got 0.
Okay. You need to shout Jesus again. No? Because the discrepancies are just too much. Anyway, give me your
0.1102.
11. 02. Okay, that's good. Any other person? Any other person? That means, Anita, your answer is standing in should I say in a class of his own or in a width of his own?
So somebody who has it 1102 like mine.
Ah, somebody else also got 1102.
Yeah, 0.1102. See there.
Who is the someone? Who is the someone now?
Is either Precious or Christine?
Okay, let's
It's not
see
me,
what.
oh.
Yeah,
I've
Krishna
not
is
done
behind the
it.
answer. Okay,
yeah,
who is someone? Who is that person? Is it Precious?
Yeah, I think it's success.
Okay, let's see, because this one is looking, at least the other one, even if anyways, let's solve it. We can't know until we solve it. So let's see. So the question is actually the square roots. I don't like this question, it's too long. I wish everybody got the same answer. 3.044 divided by 0.621 times 0.0404. Okay. Let us see who is correct. So we have our numbers here as well as their logarithm on the other side. So first of all, let's take this. This is 3.044. 3.044. All right, so we have 3.044 as the numerator. Now, what would be my characteristic?
2.
Is it 2?
It's 0.
Is 0. I think I know what it is. So you did 3 minus 1. Forgetting that 3 is just one integer. Right? It's not the value. It's the number of integers that are there. Yeah, it's only one integer that is here, which is 3. It's only one integer that, of course, one integer that is there, which is 3. So here is 1 point. So let's look for 30 under 4, difference 4. So let's go to our 4-figure table and get 30. Oh, sorry, I'm under the anti-log area. So I'm looking for 30 under 4. 1, 2, 3, 4, 5, which is 4829. 30 under 4, then difference 4, which is 6. So we have 4829 plus 6, which give me 4835. So we have 4835. Are we following?
Yes.
Yes, sir. Yes, sir.
Did somebody say no?
No, sir.
Okay, I thought I heard no. All right, so this is for the numerator. So this numerator is going to be divided by, so let me cut it. So it's going to be divided by whatever we have at this denominator. So I have 0.621 multiplying 0. What do we have? 0.0404. So we have 0.04.
Wait, before you solve, I've got my answer.
Okay, what's your answer?
11.02.
11.02. So we have 3 11.02s.
See?
So okay. We'll find out. Okay. All right. Thank you for your input. So we have this. What will be my characteristic?
Bar 1.
Bar 1. So what will I look for? 62 under 1. So let's look for 62 under 1 together. 62 under 1 is what? 7931. So right here we have 7, 9, 3, and 1. Then multiplication here will change to what?
Addition.
Addition, correct. So we have plus. Then what will be my characteristics for this?
Bar 2.
Bar 2, correct. So we have bar 2 point. So I'm looking for 40 under 4. So together, let's look for 40 under 4. What does that give me?
6064.
6064, correct. So we have 6064. So let's add to get our total value for the denominator. So this is 5.
9.
Okay.
9.
Okay.
3. Carry 1. 13 carry 1.
Yeah, so 1 minus 1 is out. So I'm left with my bar 2. Right?
Yes, sir. Yes, sir.
All right. So our denominator is sorted out. So what we need to do is just numerator divided by denominator. So let's go and do that over here. Numerator, which is 1.4.
So how will bar 1 plus bar 2 give us bar 2?
How will what?
Bar 1 plus bar 2 still give us bar 2.
Okay, you're asking me how bar 1 plus bar 2. Now don't forget, when we added 7 plus 6, we had 13, which is 3, carry 1. Now if you have 1 plus minus 1, are you getting me? If you have 1 plus minus 1, what would that give you?
0.
0 right ahead. So that's 0 plus minus 2 gave us this bar 2 here. Is it clear?
Yes, sir.
All right. So let's go here and now do our 1.4835, which is our numerator, 1.4835 divided by, which is minus, bar 2.3995. So we have 3995. So let's see what our answer will be. So let's subtract. What do we have here? 0. Now 3 minus 9 wouldn't go. So I'll come here and borrow. Here will be 7 and here will be 13. So 13 minus 9 will be 4. Use a different color, but no need. Now 7 minus 9 wouldn't go. So I'll come here and borrow. Here will be 3. I'll now have 17. So 17 minus 9 will give me 8. I hope we are together.
Yes, sir.
So we now have 3 minus 3, which is 0. Point. Now 1 minus bar 2, what does that give me?
Yes, sir.
It gives me what?
It's 3.
3.
3. Yes.
It's actually 3. Because remember, I told you bar 2 is a notation for minus 2. So this is like say 1 minus this minus here, then minus 2. Minus 2. So minus and minus is what? Is plus. So 1 plus that 2 gives birth to the 3 that is there. Do you get me?
Yes, sir.
All right. So we now have our answer for the fraction. But then our answer was the square root of the fraction. So we go on to say square root of the fraction. Square roots of this fraction. Square roots of, I can't write the full, so I'll just write square root of fraction. So it's going to be this fraction which you have gotten to be 3.0840 divided by what? Divided by 2. And what does that give me? 15420. I hope we are together.
Yes, sir.
Okay. So this is what it gave us, right? So when I divided this 1, remember 1, that 10 is 5, here is 4, here is 2. Yes, so that should be correct. So let's go back. Let's go back to numbers. So I'll write it down here as 1.5420. So we'll go back using anti-log. So 54 under 2, no difference. That's difference 0. That means there's no difference. 54 under 2, 0.54 is 0.54 under 2 is what? 3483. So for me to have one number here shows that there are two numbers before the point. So it's 34.83. Did I miss out something?
So it's your answer.
Yes.
Because so me, I've seen where I made mistake, and that's my own. The only mistake is that converting that 3.044 to log. I mistakenly did I not put the 1. No, I not put the 1. That's why I made mistake.
Well, let's check. Let me confirm the answer. So, wait, the denominator on the question, was it only 2 or were they 3?
So they were 2.
Okay, so that means I have just 2 correctly. I thought probably they were 3. Okay.
Sir.
Yes.
So the characteristics for the 3.044 is it going to 0?
The characteristics for what?
The first one is not meant to be 0.
Oh my God, that's true. That's true. That's true. And that scatters everything. But we had 1 digit there, which is supposed to be 0. So it scatters everything.
No, it's not really scatter.
Yeah, just to reward this point.
Yes. It's going to be like 2.0840.
So basically everything here stands except for this point that we have 2. Yeah, it should be 2, right? Let me see.
Yes, meant to be 2.
So everybody made mistake.
No, they are correct. I was one that made mistake here. The characteristic, that time that you said 2, I remember that I was trying to tell you that it's only 1 digit that is here. Erroneously, I put that 1 there instead of writing the characteristic as 0. So from here now, we now have 2 points. It's not really that stressful to correct the mistake. So because here it becomes 2.0840, and when you divide it, it gives you 1 point. No, I shouldn't have taken that off. So it gives me 1 point, only here changes. 1.0420. Am I together? Are we together? Where is everybody?
Yes, sir, we're with you.
Yes, sir. We are together.
So this gives me 1.0420. And when you now convert that, let's see what that's going to be.
11.0.
So what will I be looking? So we have 1.0420, right? So let's go to our, where are we? Our anti-log. So we have 0.04 under 2 difference 0. 0.04 under 2 is 1102. Then no difference. So that's 1102. But then having 1 here is showing me that there are 2 numbers in the characteristics. Okay. Yes. So that means team 11.02 is correct. Who got 0.11? That means you were close. Something must have happened to your characteristics. That means somehow you got by 1 here. Okay. Any questions?
No, sir.
So moving on to our work for today. Yesterday we stopped at sequences and series. We're dealing with sequences as well as series. And I said a sequence is a list of numbers that follows a particular pattern or a defined rule. So normally, like if you are dealing with some examples, they have a particular topic that's called pattern, but yeah, we're not looking at patterns. We're looking at, let me just show you an example anyways. At least it's quite fun. So I can get the idea. Did I even save it here? That's the question. If I saved it here. Let me see.
A sequence is what again?
It's a list of numbers that follow a defined rule or pattern. I'm trying to show us something. I hope I saved it here. If I didn't save it here, then there's a problem. Come in. Give me a while. Now, I don't know. Let me see if it was this one. Okay, something like this. Okay, yes, good. I saved this one. But this one is not really like our main discourse, but it explains what we are looking at. Now look at this. This question says that these patterns are made of sticks. So this pattern are made of stick. Pattern 1, we're given pattern 1, pattern 2, and we're given pattern 3. So we are told to draw pattern 4. It's quite simple, right? Pattern 4 will just be, now if you look at pattern 1 stick, 2, 3, 4. So I have 1. I have, yes, that should be enough. 1, 2, sorry. So I have 1. Why is it not showing? Something is wrong with my pen. Okay, no, let me do it here because I don't know what's happening. My pen on that particular page is not working. So let me use this one. Now, this one says we should identify pattern 4. So looking at it, according to the defined rule, right? According to the defined rule, for pattern 1, we have 1, 2, 3, 4. So to draw pattern 1, I have 1, 2, 3, 1, 2, 3, and 4. This is pattern 1. Pattern 2, we are having another 1, 2, 3, but it joins with the first one. So I have 1, 2, and 3. So this is pattern 2. Then pattern 3 joins with the second one. So I have 1, 2, 3 joining it. So I have 1, 2, and then 3. Like this. Are you following me? Now the next time we should draw pattern 4. Pattern 4 will be easy. Is it not?
Yes,
It's just going to be 1, 2, and then 3. So this is pattern 4. These are pattern 4 will look like. Now, the next one says, how many sticks will be in pattern 10? Now, how many sticks will be in pattern 10? We have 1, 2. Now, in pattern 1, there are many. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So, in pattern 4, there are 13 sticks. But I'm noticing something. Let's watch this.
So,
There'll be what? Yes?
So can't you do like this? Like after counting the pattern 1 itself, that is 4, then the remaining 9 is 3, 3. So you do 3 times 9, which is 27. And you now add it to the 4, 31.
Yes. That was one way. Though I wasn't thinking of this way, but that's really, really awesome.
Sir.
So that would be, yes?
Sir, please, I don't understand.
Okay, let me re-explain. Now, this is like sequence and series, only that this one is definitely about patterns. They are not using numbers. Now, the first one says, these patterns are made of sticks. So we have pattern 1, is made up of this, which are 4 sticks. Pattern 2, we are having an additional 3 sticks coming to join it because this one is here. It is the same stick that is used to continue pattern 2. Then to continue pattern 3, the stick from pattern 2, which is here, you have 3 additional sticks joining it. This is just the pattern. They gave us the pattern. Then they said we should draw pattern 4. So that what will happen is that pattern 4 will stop. From the stick of pattern 3, you join an additional 3. Is that correct?
Yes,
this is the A. So this is the A that says draw pattern 4. Now the next part that now says how many sticks will be in pattern 10. So like Anita said, very, very perfect way of doing it. That since each other pattern adds 3 to the other one, that we can just say to complete this as 10, I will have 9 more. It will be 9 times 3, which is 27. That's to form the 9 other patterns. So 27 plus these 4 here, because only this one has its own 4 complete sets. The others are just joining 3. This one too is joining 3. This one too is joining 3. So that means the 27 for the 9 entire set plus the 4 here will give you 31. So how many 6 will be in pattern 10? It will be 31. Though, like I said, I wasn't even thinking in this line. And that's why I always tell my students that mathematics is dynamic. It's not static. Now, this is what I was thinking. Let me show you my own line of thought. Pattern 1 has 4. 1 has 4. Pattern 2 has how many? Just looking at pattern 2, let me count from here. Pattern 2 has 1, 2, 3, 4, 5, 6, 7. Pattern 2 has 7. Pattern 3 has how many? I'll count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Pattern 3 has 10. Are you noticing something? To form the pattern, it is the number of the pattern times 3. Then you add 1. Are you noticing that?
So you add 3 to the numbers, like 1 is
You
4.
multiply 3. Then you add 1, right? Like here is pattern 1. It had 4, which is 1 times 3, then added 1. The next one is 2, which is 2 times 3, then added 1. So for 10, it will be 10 times 3, 30, then you add 1, which is 31. So you see, despite the fact that I was not even seeing that, as far as it is correct, you get the same answer. So they say how many 6 will be in pattern 10? How many 6 are going to be there? We're going to have 31.
Sir.
Yes?
What I was seeing was that you're going to be adding 3 to them, like 4 plus 3, 7, 7 plus 3, 10. And then keep adding 3.
Wonderful. I see. I didn't even see that also. Correct. That's very, very correct. Because if you check it, you have 4, right? And that's true. I didn't see that also. This is 7. This is 10, right? 13.
So are we doing quantitative reasoning here?
Kind of. Kind of. So 19, 22, 25, 28, and then 31. Correct. Now you see, each of these 2 methods that both of you mentioned, I didn't even think of them. I just only noticed the recurrence of the patterns, and then I was able to use it. But you see, we all arrived at the same answer. So basically, that's what sequence and series is about. It's about knowing the rules that are used to form that sequence, and then with it, you can be able to, just like if you are a matchstick company, for example, because this is applicable. If you're a matchstick company, you know how many sticks make up a particular pattern of like, or even all those tilers. Tilers also use something like that. Maybe you have to make a pattern of ties. Have you seen those patterns of ties before on the floor? Of course, you would have. Not the normal color ties, like some that we have, something like maybe triangular face, like different pattern. I'm just giving one, something like that. You're getting me?
Yes, sir.
Yeah, so these things apply to sequence series because you need to know how many of each slab needs to have this triangular face and how many you need to produce two complete tiling materials, three complete tiling materials like that. So that's basically what sequence and series is. Only that this one is for a foreign exam, by the way. It's for a foreign exam. They don't use numbers because according to maybe their point of reason, numbers are easy, right? They use things that will require you to think a little bit. Who can try this other one? They gave us a pattern of dots here. So they said continue the pattern to show pattern 4. That means first of all, you need to know the rule or the way the patterns are being formed. Well, what kind of deviate,
Sir,
Yeah.
sir, look at that this easier. So the first one
Yeah.
have dots. The second one
Okay.
have dots. Then with 4 extra dots.
Sir, they
Okay.
are adding 4.
They're adding four dots
to each pattern.
They're adding 4 dots to each of them.
So give me how would you draw pattern 1? Tell me. I mean pattern 4. You have to pattern
Pattern
4.
4 will be dot, 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 dot.
Give a systemized answer. Now, like maybe dots from this dot, I will always start from center. Is it that here will be 7 and the other one will be 10? Give me something like that.
Like how it will be black. I look at
The other one will be 7.
Okay. Let me call. Our class is getting chaotic. Who was that person speaking first? Is that Christine?
No, it was me.
Okay. Yes. It was you. Go ahead.
Sad, that one, but the two sides will have 7 dots.
7 dots, okay? That's 1, 2,
Sorry,
3,
8 dots.
8 dots.
Yes.
So that's 1, 2, 3, 4.
Oh, that's why I made mistake. 7, 3 here, 3 there. It's 7. Sorry.
Okay. Let me get my central dot first. So this is my central dot. Let me. I'm coming. Let me get my central dot so that I'll get what exactly you meant. So you said 3 here and 3 there, right? So
yes,
1, 2, 3. 1, 2, 3. Then here to the same thing. 1, 2, 3.
1, 2, 3.
2, 3. Okay. Is there anybody with a contrary pattern?
So my own pattern is that looking at it in a V shape, like V up and then V down.
Okay.
Yes. So those dots now. So like with the dots too.
Yes.
So those dots now, since in pattern 2 it was 1, pattern 3 is now 2, so pattern 4 will be 2. So like 2 will be 3, sorry. Pattern 3 was 2, so pattern 4 will be 3. So you have
That means there's always central dot.
Yes.
So pattern 4 will be 3 up and 3 down, like that, right?
Yes. V pattern.
Okay. Is there anybody that saw another method of making the pattern?
Yes, sir.
Yes. What's your own method?
Adding extra 4 at the edges.
Adding extra 4 at the edges, like let me get you. If this is your central, let me mask this. I'm coming. I'm coming, please. Let me mask this so I can move it around. So, if this is your central dots, Yes. So what will I do? You said I will add extra 3 or extra 4.
Extra 3, sir.
Okay, which is the same thing here, right? No, I meant like, yes, we have identified the fact that it will be extra 3.
At the edges. Extra 4 at the
4.
edges, like at the edges.
Yes. Okay. But I don't think that pattern will be correct. If I had 4, that's 1, 2, 3, 4. 1 and 1. Would it be correct? I think it will be more than. But anyways,
Sir,
like
the opposite side.
At the opposite sides, like I'm not getting you. Like, do you mean here I'll add extra 1, 1 or 2, 2? Are you there?
Sir, the place where the dot, the first dot is located at.
Yes.
When you come to that side, that first side, you add 1. You now go to the opposite of that first side.
Okay. Like, okay, I think I get you now. You add 1 here, you add 1 here, right?
Yes, sir. Yes, sir.
Okay, good. That's the beauty of this particular question, because the way I saw it is this. If you have one pattern, like for pattern 1, you add 0 patterns across. That means it is n minus 1 in terms of across. That's the way I saw it. Like now, if I have pattern 1, that would be n minus 1. That means across, which means this 1, 2, 1, 2. That's what I mean, the across. So for pattern 1, it will be n minus 1, which is 1 minus 1, 0. So no 1 will appear. So that's why it was only 1. Are you getting me? For pattern 2, after 1, how many would you have across? It will be 2 minus 1, which is 1. So I'll have 1 here, 1 here, 1 here, 1 here. Then for pattern 3, n minus 1 across will be 2. So after central 1, I'll have 1, 2, 1, 2, 1, 2, 1, 2. So either ways, we all got the same pattern, right? Because for pattern 4, how many will I have across? I will have how many? 3, which is 1, 2, 3, 1, 2, 3. This is my central one. Let me circle it. Then here we have 1, 2, 3, 1, 2, 3, which is the same with what each of us got. Because here 1, 2, 3, here 2, 1, 2, 3, good. But if you notice, we all got it using different point of view. Is that correct?
Yes, sir.
Yes, sir.
Right. So if you look at this, now the now says how many dots will make pattern 6? How many dots? Now there are many ways of doing it. Is either you draw pattern 6 or you find a way also, a rule for getting the number of dots in each pattern. And I think that one will be faster. This is what I mean. For example, pattern 1 had 1 dot. Pattern 2 had how many? 1, 2, 3, 4, 5. Pattern 2 had 5 dots. Pattern 6 had how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. Pattern 3 had 9 dots. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. Pattern 3 had 9 dots. So and what's going on? Anyways, how many patterns will pattern 6 have?
Pattern
Are we there?
Yes, sir.
Yes.
Pattern 6.
So how many dots will you have?
That would be like 10.
23.
Jesus.
23. What's that 23?
21.
Let's see. Okay, we have 23, we have 21. So let's see.
20.
26.
26.
Bye. Sir, 20.
Okay, is it the 21 person that changed to 26?
No, I'm still on my 21.
Okay, 26 that changed to 20.
No, sir, 20 is on his own.
Okay, 20 is on his own, then 26 is still there.
Yes, sir.
Where are the ladies? Where are our ladies? Where are we?
So we're here.
Then our makeup.
I'm changing to 20.
Yeah.
25.
So how many dots will be in pattern 6?
I'm changing to 25.
1 plus 4 plus 4.
25. 20. Who is changing to 25? Or is he on his own?
The 26 person.
Okay, 26 is changing to 25. Yes, ladies. They said ladies first. So people were supposed to go first.
Yes, clock it.
21.
Okay, we are having 21. This one, the ladies are united in the answer. Guys, what's going on? Okay, let's come together. Guys, come together. 25, 21, 26.
Which number?
They said how many dots will be in pattern 6?
Okay, sir, please wait.
Okay. Guys, let's come together and bring out one answer.
Size 21.
I saw
21.
21.
Ladies are saying 21. Let's see. Okay.
Sorry, sir, 22. 22. Sir, 22.
Oh, 22. Okay.
Yes.
Like we're counting from 20 to 20. Who will give me 24? Let it be complete.
So I saw something.
I
saw something.
Yes, what did you see?
From this 1, 2, 3, you wrote and 159, we're adding 4 to them.
Yes.
So that's not the case from what I saw.
Yeah, so what did you get? 24. Let it just be numbers that follow themselves.
No, so I said 21. No.
Okay, you said 21. Okay. Nobody wants to give me 24. Okay, let's see. All right, so we've identified the pattern, right? The thing is just look at the pattern, observe it. 1 had 1 dot. 2 had 5 dots. 3 had 3 dots. So that means 4, we have how many dots? 4, 5, and 6. 4, we have, like she said, it is adding 4. So here will be 13. 5, we have 17. Then 6, we have 21. 21 is correct. Or, since you have already known how the dots are being formed, we said n minus 1 across. And that's how many dots will be in pattern 6. Either way, you should give us the same answer. This is pattern 6. So it will be n minus 1 across, which is 5 across. So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So let's count our dots. Follow me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So you see, pattern making, sequence and series, as long as you get the rules, doesn't matter from which lens you are viewing it. Like as you can see, in each of the last 2 questions we solved, we all got different ways we were able to see how that pattern was being formed. Now, this one is a bit interesting. They said, which pattern we use 77 dots? Let me show you the pattern. They said, which pattern we use 77 dots?
Sir, so that means you have to use that your formula.
Okay. So solve. Let's see. Help me. So once again, so that means here 21 is correct. So let me rub this off so I have space to write our new answers, whatever we get. So what pattern we get?
Wait,
we have.
sir, did you just say 77?
77, yes, this. Which pattern we use 77 dots?
Sorry.
So at the end, is it number of patterns?
You know, this is the formula I saw. You may see something different, but if you are talking of my formula, I said from the central dots, to get the number of dots you need, it will be n minus 1. So that means across, for example, here is 2 is n minus 1, which is 2 minus 1 across. 1 year, 1 year, 1 year, 1 year. Here is 3 to be n minus 1, which is 2 year, 2 year, 2 year, 2 year. Yes?
Pattern 20.
Pattern 20. Okay. Okay, we're having pattern. I like it. Our answer is, even our answers too are in pattern. Are we noticing? So we have 19, we have 20. 21, who will get 21?
So let me explain.
Okay.
So 19, oh.
19, oh, okay, oh, 19, oh, okay, oh.
So because when in 77, like 77 dots,
Yes.
we'll first minus pattern 1 from it, and which will give us 76. Since from pattern 2, it keeps adding up 4. That's 76 that we minused 1 from it. We use 76 divided by 4, which will give us 19. Then we'll add that. Then that is 19 pattern.
19.25, not 19.
Well, let's say 76 divided by 4 will give you 19.
Yes, then we'll add pattern 1 again, which will give us 20 patterns.
Okay, that's how you got your 20. 15. Yes.
So actually, I did not solve it, but when Henry said 19, what I used to do is that I'll minus that 1 from the main number, giving us 76. So divided by 4 will give us 19. So because that number in the middle, that is why it's looking like an odd number. So the main answer is this 19, just like the 6. The 6 was 5 times 4.
That is pattern 20.
As well. 9 times.
Leave the guy with his answer. Which is Hazal. Okay, please go ahead. I can hear you.
That is pattern 20. I just calculated it now.
It's 20.
Manual way.
Pattern 20. You will not be complete.
Pattern 20, like pattern 20.
Okay, I've heard you. Pattern 20, pattern 20. Yes, 15. How do you get your own? You were saying something before you got your.
I've never solved it before. What I did was that I'll minus that 1 from the number.
Okay. What number? Sorry. That's the 77.
76. So 76 divided by 4, that is 19. Okay, I've seen
what happened to the minus 1?
It's 20. It's 20. I just realized now.
Okay.
We are correct.
You
All right. So the answer is actually pattern 20.
Let me tell you how I calculated my own.
Okay, tell me how.
Okay, sir. So if pattern 2 is 5, I started adding 4. So I got to 7 on the dot. Then counted. It gave me pattern 20.
Okay. Okay. That's good. Yes, that will give you the answer. Yeah, what's going on? Yeah. All right, so that will give you the answer, right? So, like David said, you could keep adding, what is it called? 4s. Was it 4s or was it 3s? Yeah, it was 4s. You could keep adding 4s, and then when you get to the pattern 20, that's where you're going to get 77 dots. All right, let's take another one. I think there's one more question there. One more, then we'll now go back. Hope we know we have derailed though. Yeah, bring it up. Are we there?
Sir. Yes, sir, we are there.
Yes. So let's do this one. These patterns now are made of sticks. These patterns here are made of sticks. Therefore, complete the pattern or the table for pattern 4. Oh, sorry.
Size 15.
Okay, 15. Yeah. Just very easy. 6 plus 3, 9, plus 3, 12, plus 3, 15. Or basically, if you want to look at the pattern way, which is too long anyways, that's too long for me. This one is 4. Then you add extra 2. This one 2, like that. The boxes keep increasing.
Yes.
You're adding extra. If you check it, what you're adding is actually 3. Yeah, the boxes were complete. You just added this 1, 2, 3 to it. Then yeah, you have these 2. You move them. You now have 1, 2, 3 to it. So that's correct. Sketch pattern 5. That was, I think by now we'll have gotten this pattern something. Let me see if there's a harder one. Let's take the hardest pattern and then we'll go back. Okay. Yes, let's take this one. So we have these patterns. Patterns 1, pattern 2, pattern 3. So how many of these are needed to make pattern 6? Are we on it?
It's at 36.
36. Okay.
No, wait, though.
Yeah, I'm waiting, of course. I'll give you a time. So we have 36.
36.
Okay. Another 36. Like this time, the boys are united.
Actually can be 36, so because it's increasing.
Okay, you don't think it can be 36?
So I think
So I did the number of tiles in total.
Yes.
Okay, sir. I'm coming.
so I got 31. Don't know.
Wait, I'm coming now.
Okay, I see reading it. Sorry. I wanted to be sure there's no additional information. They said here is a tile. Here is the sequence of patterns made from this tile. Yes, no additional information. So how many is needed for pattern 6?
So I got 31.
31. Okay, 31. 36. The guys are
Wait,
getting 36.
so I did the number of tiles in total.
Yes, number of tiles in total.
Okay. So I got 189. 89.
189. Okay. Somebody else.
Sam with Anita on this one.
189. Or 36.
No,
I think I
the,
need to say 36.
no, the 180 something.
So
Okay,
no,
189.
I said 189.
Okay, Anita was the one that said 189. Okay. All right. Any other person?
So I go with Emeka.
30.
139. I go with Emeka.
100 and what?
139. 89, sorry.
This is why I'm saying 39, 89. Okay, how did you arrive at 189?
Sorry, sir. It's 187, not 189. For adding. Yeah. 87.
Okay.
Yes.
Okay, Chukwemeka. Where's Chukwemeka?
I'm here, sir.
How do you arrive at 289?
So I know, sir, I did not actually solve it, but I know that it cannot be 30 something because as the thing enter another level, it's as if it's increasing. The 6 is increasing by 2. So by the time it will have reached, you cannot see the.
Okay. Yes. So first of all, who can this pattern being formed? How is the pattern being formed? Who can tell me?
So like the first one is 1, second one you bring 6, third one you bring 2 times 6 plus 1.
Remember, it must work for all of them. If you are saying that's the pattern, it should work for one. But go ahead. Let's put it to test.
Yes, it's actually going to work. Then you're going to do n times 6 plus 1. So
Okay, wait, sorry. Let's come again. You said your pattern is what?
Like n times 6 plus 1.
N times 6 plus 1. Okay, let's check that.
I'm even confused here. Oh, so it worked for 3.
It worked for what?
3.
It worked for 3, but it didn't work for 2 now.
For 2.
2 times 6 is 12, plus 1 is 13. And how many do you have? 1, 2, 3, 4, 5, 6, 7.
No, for 2.
Yes, so that means it won't work. So, yes, who else? What pattern did you see?
91.
91.
Yes.
Okay, 91. How did you arrive at your pattern?
The common difference is increasing by 6 as it goes on.
Okay.
If you continuously add it, you will reach 91.
Okay. All right, so we have 36, 31, 189, 187, 91. So what do we, any other person before we go on? Any other person? Okay, no other person, so let's go on. So now if you notice something, like I said, the way I see the pattern may not be the way you saw the pattern. But one thing we cannot agree, at least we have seen it from the dots. We had like 3 different ways, different people view the pattern, but they were all sync. They were all in sync. They were all giving us the same result. So now this is the way I'm seeing the pattern. Now there's a central one inside, which is that what I call this. Ladies, please, if I call this pink, now they can tell me that it's cockroach red or something. What color is this? What color is that?
Answer.
Huh?
Light peach.
Okay, light peach. Okay, let's go with that because me, I was looking at it, I was thinking pink. That, but anyways, who am I to argue? So, if you are saying the central one, what is happening is that the outer layer, for me, from the way I'm saying the pattern, is the double of the layer before. So, for example, here I had 1. So, outside, what am I going to have? I have 1 times 2 is 2. Well, no. That pattern is not going to work. I just even saw that. That pattern is not going to work at all. Six. The next one is 12. How many patterns are here? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 3. Yes, 12. So basically, I have 1. I have 6. Here. 1, 2, 3, 4, 5, 6. And then here, I have 12. So, this is pattern 1, having just 1. This is pattern 2, having 7. Let's see if we can look at the pattern in terms of number. Pattern 1 has just 1. Pattern 2 has how many? 1, 2, 3, 4, 5, 6, 7. Let's see if that will work. Then pattern 3 has how many? This is 1, 2, 3, 4, 5, 6, 7. 7 plus 12 is 19. Is there a way of getting how it's working?
The common difference is increasing by 6.
No, so I've seen something. Like
Not
1
increasing by
plus
6 because
1
here
plus
is
6.
13. Yeah, ought to be 13. Yes, somebody, yes?
1 plus 6 is like adding it with multiples of 6. 1 plus 6 is 7. 7 plus 12 is 19. Then 19 plus the next multiple of 6.
Yes, that could work. That could work. So let's see it. So as I said, we must identify the pattern first in order to move forward. Now, like you said, 6 will not work in itself, but a multiple of 6 is working. Because if I add 6 here, the first multiple of 6 is 6. Next multiple of 6 is 12. Next multiple of 6 is 18. So 19 plus 18 should give me 37. Next multiple of 6 is 24. So 37 plus 24. Let's add the 24 here.
61.
No? Okay, yes, 61. 61. Next multiple of 6 is 30. So adding it gives me what?
91.
91. So that means pattern 6 would have 91 total times. Is there any other way of viewing it so we can see if we arrive at the same answer? Who got the 91 initially? Anita, right?
No.
Who got the 91 initially?
Cheesy, no.
Okay, Chizi, no. Okay, how did you arrive at 91? Let me know if you had it. If you know, like I said, the way I see it might not be the way you saw it. So how did you arrive at 91? Is it there?
Wait, sir, but what is the answer?
It's 91. I just wanted to see if there's another way somebody observed the pattern.
Oh.
Now, looking at the way the pattern is being formed, right? They are adding multiples of 6. Here is pattern 1 plus 6 gave me the next one for the next pattern, which is what's it called? 7. 1 plus 6 is 7. The next multiple of 6 is 12.
So, for me, the way I saw it is that every time you're adding times 2 of the next number. Like after 6 times 2 of 6 is 12 times 2
Yeah.
of 12.
I also saw it in that way, but I noticed something is not going to work because if I'm saying that, then the next one should have been 2 from the first one. The outer layer, are you getting me? Should have been 2. Because if you are multiplying times 2 of the initial one, here should have been 2, then 3. Because that's what I thought initially. I saw that that's not going to work. Because the initial layer here is 1. The outer layer here should have been times 2, which is 2. Then the next layer should be 4. But I can get why you felt that way because here is 6. Here is 6. So the next outer layer was 12.
Yes, sir.
But each rule must work for the entire sequence. I told you that the sequence follows a rule. So if that pattern did not work from pattern 1 to 2, I cannot use that pattern from 2 to 3, 3 to 4, 4 to 6. So that's how I was asking. Is there any other person? Since Chizino was the first person to get that 91. Now this way we arrived at 91. Was there a different way you saw your own 91? Remember, there may be something I'm not saying that you are saying. That's why I want us to collaborate. Where is he? Is he in the class?
Yes, sir.
Children, are you there?
Yes, sir.
So how did you arrive at 91?
Addition.
Wait, let me hear him. Yes? Go ahead, the person that got 91.
Sir, by the continuous addition of the multiples of 6.
Okay, the same way.
Yes, sir.
I was asking, somebody else mentioned 91 before now. Was it you?
No.
Who was that?
That was me.
He said it was one. Okay. Yes, 91. But let's observe. Let's observe. There can't just be only one. At least for the other one, we're able to see like 2, 3. Let's see. Can we notice another way here? There has to be another way. There has to be another way. Is there another way? Let's think. We've gotten the answer, but I feel there should be another way. It can't just be only this method that we observed. Well, I can't find any other pattern, but anyways, this rule works. So we adopt it. So the number of patterns needed to make pattern 6, or the number of tiles rather, needed to make pattern 6 is actually 91. So that means choosing one was correct. Let's take one more. I think we'll just end. After 11, supposed to round off. So let's take one more. One more. After this one, we end the class. So in the next class, we start.
So this one is doing in multiples of 2, like 2, 4, 6, 8.
Are you sure?
For the yellow.
Okay, for the yellow. Okay.
Yes.
So that means how many yellow triangles are in the nth pattern? That means 2n, because they told us in the n's. That means any number at all, 2n. Because for pattern 1, we have 2 yellows, which is 2 times 1. For pattern 2, we have 4, which is 2 times the 2. That's pattern 2. For pattern 3, we have 2 times 3, which is 6. 1, 2, 3, 4, 5, 6. That means the answer here will be 2n.
So, but the blue triangles is odd number. So
what will be the number in the nth pattern? Plus 2. M plus 2, correct. M plus 2. Because for the first one, wait a minute. It doesn't work.
So it's working. 1 plus 2 is 3. 3 plus 2 is 5. 5 plus 2 is 7.
They said how many blue, not total. For pattern 1, we have 1 blue. And if you put it here, it's going to be 3. So it doesn't work. It works for pattern. Do we get what I just asked? I said the n plus 2 will not work. Because they said how many blue triangles are there in the nth pattern? For example, in pattern 1, we have 1 blue. For pattern 2, we have 3 blues. We have 3 blues. For pattern 3, we have 1, 2, 3, 4, 5. We have 5 blues.
That is odd numbers.
Odd numbers, right?
Yes.
But we have to give a formula for it. Just like this one, we give 2n. It works for the yellow. So how do we get a formula for the nth pattern of the blue? Let's think.
N minus 1 plus 2.
N minus plus 2, we are complicating it too. N minus 1 plus 2 will still give you n plus 1. So does it work? No. Pattern 1 will give you 1. Pattern 2 will give you 3. Pattern 3 will give you 4. It doesn't work. So let's think. Okay, let me help us out. 2n minus 1. Let's try. Now, if you look at pattern 1, for the yellow, I'm talking of the blue, sorry, for the blue. 2 times 1 is 2, minus 1 is 1 blue pattern. Pattern 2, 2 times 2 is 4, minus 1 is 3 blue patterns. Pattern 3, 2 times 3 is 6, minus 1 is 5 blue patterns. Does that work?
Yes, sir.
All right, so that's the nth pattern for blue, 2n minus 1. That means basically how I got it is this. I observed that for every number of yellow, the blue will be reduction of 1. For example, here there were 2 yellows, 1 blue, 4 yellows, 3 blues. Because it's not something of calculation. I didn't calculate to get there. It's just by observation. Here there were 1, 2, 3, 4, 5, 6, 6 yellows and 5 blue. And we've gotten the nth term for yellow to be 2n. That means to get the blue, it will always be less by 1. That's why I write that this. Are we following?
Yes, sir.
All right. Now the next one, which is I think the last, yes, is the last under that pattern, says how many triangles, both yellow and blue, are there in the 100th pattern?
100.
Yes.
So for the yellow, it will be like n plus 2.
It's 200 yellow and 199 blue.
Yes. 200 yellow and then 199 blue. That means you are saying that there will be 399 triangles in total. Is that correct?
Yes, sir.
Okay, let's check. Can we get a formula for
Yes,
getting
sir.
the pattern of total triangles, whether yellow and blue?
Open bracket 2n close bracket plus open bracket 2n minus 1.
Sorry, come again.
2n close the bracket
Hmm.
time n plus open bracket 2n minus 1.
So that means we're saying 4n minus 1 will give the total number of triangles. Let's see. For triangle 1 or for pattern 1, we have 4 times 1 is 4, minus 1 is 3. So we have 3 total triangles, correct? Then for pattern 2, we have 4 times 2 is 8, minus 1 is 7. We have 7 total triangles, correct? Then for pattern 3, we have 4 times 3 is 12, minus 1 is 11 total triangles. So let's try it for that. Let's try it for that 100. So 100 will be 4 times 100, 400, minus 1, 399, which means that we are correct. So 200 yellows and 199 blue is correct. So basically, this one is not difficult. It's just understanding the rules and patterns that make up the rules. Then remember, sometimes, like in this one, that one of doubling, it worked from 2 to 3. But the pattern must work from 1 to 2, 2 to 3 for it to be adopted. So that's why the one of the multiple worked. The other one of doubling did not work because we're supposed to have, from here, we're supposed to have 2 and then 4 to be the next pattern here. So that's it. Let me give us an assignment. This one says Harry wants to find the number of dots in pattern 50. I don't think this one is going to be.
Shall I get the assignment?
Yeah, I wanted to give us an assignment, but I'm looking at it that it's not. Or it's something we can just do straight. It says Harry wants to find the number of dots in pattern 50. Write down the method he could use. How do you think Harry can find the number of dots in pattern 50?
2n minus 1.
2n minus 1.
Like 2n
No, I'm talking of this pattern. I've moved to a new pattern.
Yes, 2n minus 1.
Okay. 2n minus 1.
That is, wait. No, 2n plus 1, sorry.
2n plus 1. Now let's see. For pattern 1, 2 times 1 is 2, plus 1 is 3, correct? It works. For pattern 2, 2 times 2 is 4, plus 1 is 5. It works. For pattern 3, 2 times 3 is 6, plus 1 is 7. Does it work? Yes, it works. So that means Henry can use the method of this nth term for number of patterns, 2n plus 1. So how many patterns will be in pattern 50? 101. Is that correct?
Yes, sir.
Yes.
Yes,
So
sir.
from here, even if you want to be like that,
Yes, sir.
1 times 2 plus 1, 2 times 2 plus 1, 3 times 2 plus 1. So 50 will be 50 times 2 plus 1, 101. So that's why I felt there was no need giving us that one. Let's do this one. Let's do this one. So this will be our assignment, please.
Okay, so wait.
Please enlarge it.
If I enlarge it, some part of the question will be
our assignment?
So I'm not getting the pattern in the first one. That is why.
Emeka,
I'm coming.
Emeka, please, can you screenshot that and send for me?
Same here.
I'm waiting, Emeka.
I'm coming.
He's not here.
Yeah, Christine, do it for me. Pew.
Not possible.
Is it not possible?
Yes.
Sir. Sir. Has he left?
Network.
Come on, I'm not talking to you. You can help me and screenshot. Leave me alone. Sir.
So class, please, sorry, I was cut off by network. But what I'll do is I'll send it across to PTA chairman, right?
Yes, sir.
All right, so I'll send it across.
And me.
Everything was clear, right? Was it?
Sir?
I said everything was clear, right?
Yes, sir.
All right, so see you in our next class on Tuesday. So bye for now. Please enjoy your break before the next class.
Wait, has he left?
He's waiting for you.
He's waiting for
You.
funny. I am this who got that assignment? Person should send for me, please.
They are sending it to PTA chairman.
Okay, they are sending to PTA chairman.
To
To us. Okay. Thank God.